Okay, question 10, the last question for this tutorial. So MatSat is a 2000 kilogram satellite that is seen stationary to the observer on Earth. It is orbiting with radius 4200 kilometers from the center of the Earth. Okay, so this is from the center of the Earth. And then the question is, why does the satellite appear stationary to an observer on the Earth? And then explain why the satellite accelerates whereas it is moving at constant speed. Okay, so the explanation for geosynchronous, it is actually a geosynchronous satellite. Like I didn't put this in your notes for geosynchronous satellite. So basically geosynchronous satellite is a satellite that is moving, but then for us to see from the Earth, for the observer to see from the Earth, it seems stationary lah, and then it revolves in the same direction as the Earth with the same period. Okay, then question B, dia tanya explain why the satellite accelerates whereas it's moving at constant speed. Okay, so constant speed does not mean that the direction is not changing. Speed here is a scalar, so okay, so it does not have any direction. So so even though it says constant speed, it does not mean that the velocity is constant. Okay, and then although the velocity has a constant magnitude, the direction is not confirmed to be constant. Okay, and then in this case the velocity is not constant because the direction is changing. Okay, so when there's a change in direction, okay, when there's a change in direction, it will cause an object to accelerate. Okay, so don't get confused whenever they say the velocity is the magnitude of the velocity is constant. Okay, does it accelerate or not? It is accelerating if it changes direction. Okay, so any changes in direction will cause an object to accelerate lah. All right, okay, so that is the explanation for that. Then so question C, calculate the centripetal acceleration of the satellite. So centripetal acceleration, we know that it is equal to AC v square over r. Okay, so from here we have to find the value of v lah, which is the orbital speed. So orbital speed is g, mass of the Earth, over dengan the distance. Okay, so the distance is 42,000 kilometers. So 42,000 kilometers lah. Okay, so G is 6.67, negative 11. Mass of the Earth is 624 over dengan 42,000 kilometers square root, and then you'll then get the orbital speed to be equal to 3.09 times 10 to the power of 3 meter per second. Lepas tu the centripetal acceleration is v square over r. So v is 3.09 10 3 square over r, which is equal to 42,000 kilometer. So you should get the centripetal acceleration to be equal to 0.22 meter per second square. Okay, so that is how you use both chapter 7 and 6 punya formulas in one question. Okay, and then the final question, we have to find the change in potential energy of the satellite as it falls through a radius of 21,000 kilometers from the center of the Earth. Okay, for this one we know that U is equal to delta U, okay, is equal to G, mass of the Earth, minus mass of the minus pula darab lah, mass of the satellite, and then this one is R what's the is where is it? Sorry, let me check. Potential potential, this one, R2 minus R1. Okay, so R2 minus R1. This one is R1, R2. Okay, so we have sudahkan R1, R2 tu. We know which one. Negative 11. If you don't know R1 tu apa, R1 tu initial punya radius. Bukan radius, sorry. Initial distance. And then R2 is the final distance lah. Okay, so this one is 624. Mass of satellite is berapa? Mass of satellite 2000 kilogram. 2000 kilogram. R2 is 21,000 kilometer minus 42,000 kilometer over 40,000. Okay, darab je lah. Okay, so you should get the change in potential energy to be equal to 1.91 times 10 to the power of 10 joules lah. Okay, right, so that is the final question for today.